want to quickly teach us how to carry out the load assessment of a building, an apartment, before we eventually determine the size of the inverter to be chosen, the size of the battery bank, and the number of the solar panels required for the installation of that building. So let me quickly take us through how to calculate the load assessment, how to assess our load and determine the load demand in that building. Now, load assessment calculation. If you look at this table, we have items in their numbers, we have the load, operation time, the power rating of each of the equipment, and the energy consumption. If you look at this item number 1 here now, we have one number of LED TV operated for 6 hours, and the wattage power rating of that LED TV is 400 watts. 400 watts times 1, still 400 watts. But the energy consumed by this LED TV in 6 hours will be 400 times 6, and that gives us 2,400 watts. If you also look at the second one, AC bulbs, make sure your bulbs are energy savers. So we have 12 watt energy savers here. 12 watts energy saver, and they are 20 in number. This 20 now, if you look at it, 20 times 12, it gives us 20 times 12, 240 watts. Then the amount of energy consumed by our bulb in 12 hours will be 240 times 12, and that gives us 2,880 watt hour. That is the amount of energy consumed by the bulb in 12 hours. Air conditioner they have in that building, assuming it is 1 and it is 1 horsepower. 1 horsepower is equal to 746 watts, and that is why you see 746 here. Multiply by one number, and that gives 746 watts. And 746 watts operated for 10 hours gives us 7,460 watt hour of energy. So now, home theater, only one is available, and it is 250 watts. 250 watts times 1 still gives us 250 watts. But if this 250 watts home theater is operated for 5 hours, it is going to give us 1,250 watt hour of energy. That is the amount of energy it consumes for 5 hours. All together now, let us add all the power rating together. It gives us 1,636 watts. And all the energy consumed in watt hour together gives us 13,990 watt hours. The essence of this power rating, the total here, is to allow you choose the right size of the inverter. But do not forget, the load in an apartment, in a building, usually grow with time. So if they have 5 items today, tomorrow it can increase to 7, 8, 9, and 10. That is why we have to calculate the 25% of this total wattage as what? Future growth factor. Then we add it to the existing load, and that gives us 2,045 watts. Generally, which means the right size of inverter for this installation is anything inverter above 2,000 watts. You can see we got 2.0, or that is 2,045, 2.045 kilowatts. So any inverter above 2,000 watts is suitable for this installation. We can get 2.5 kilowatt inverter. You can get 2,300 inverter, 2,200 inverter. Any rating of inverter above 2,000 watts is suitable for this installation. Now, for you to know the number of panels required for this installation, just like I said in my previous video, you are going to calculate it this way. You can check my YouTube channel for the rest of this video. For you to know the required number of panels to power all the domestic load in that building, because I said in my previous video that make sure you calculate the total load existing in that building so that you know the number of panels required to service the load and the minimum number of panels required to charge your battery. The sum of the two will give you the total sum of the number of panels required for that solar electricity installation. Now let us see the number of panels required to service the load appliances demand for that building. Now, the number of panels is equals to, let's assume we are going to use 350 watt panel. Mind you, if you are using 350 watt panel, it has to be uniform all through. Do not mix panels of different ratings together. So I assume 350 watt panel here now. 350 watt panel here, the formula I'm going to use is the energy demand, which is the one I calculated earlier, which is 13,990 watt hour, divided by power in each panel, which is 350, multiplied by loss factor and by location factor. Do not forget, the loss factor that I assumed earlier is 0.75. I said the system efficiency can never be 100%. So, but we assume 75%, and the factor to be applied here is 0.75 as our loss factor. Then we are going to multiply it by location factor. How do we get the location factor? Depending on the company you are buying your solar electricity gadget from. I check the data from the database of a particular company using global solar atlas.info. When I use this, I impute my location, my country, and it gives me the location factor of 4.5. So, you know, location varies, and the location determines the number of panels. You know, if you are in Nigeria, the Nigeria weather is hotter than the European weather. So you may require more few number of panels in Nigeria and require more number of panels in Europe. So that is why it is essential to consider the location factor. And the location factor I'm assuming here, taking data from this website, is 4.5. So it depends. You can equally visit the website of the company you are purchasing your equipment from to get your location factor, so that it will enable you calculate the number of panels required. So if I apply all these values now, 13,990 divided by 350 watts in a panel, multiplied by loss factor 0.75, do not forget, times 4.5, which is my own location factor. I'm in Nigeria, Lagos. Location factor is 4.5. So if I carry out this, I eventually am going to have 11.84338. But since we cannot have decimated number of solar panels, we have to approximate it to the nearest whole number. And the nearest whole number here is 12. So we now need 12 number of 350 watt panels to service all the domestic appliances in that building. Minimum number of panels required to charge your battery, don't forget, we've calculated it earlier as 4. So if I add that 4 to these 12, the total number of panels required in that solar electricity installation for that building is now 12 plus 4, which is 16 panels. 16 number of 350 panels. And that is how to calculate, how to determine the number of panels, how to choose the right size of inverter, and how to determine the battery bank capacity will be delivered and discussed thoroughly in my next video. So till my next video that I'm coming to your view, your one and only Engineer Oxford, I'm going to see you in my next video by God's grace. Till then, peace.